All right, 10. So I also had a request for number 17. So the cables of a suspension bridge form parabolas. If the minimum point of the center cable is placed at the origin, determine an equation for each parabola, and then describe the values of x for which each equation is valid. So, so they're saying, right, that this minimum point is going to be the origin. So let's go ahead well, let's go ahead and put a axis on our bridge. Okay. Whoops. All right. So if I start with the center parabola, okay. So let's do this one. Then what I know is that this is 0, okay? The whole width of this bridge is 100, so that means to go from, right, if this is in the middle, then I know that this is going to be 50, and this is going to be negative 50, okay? And it tells me that the height of the parabola is 30. So what I then know is that this point right here, okay, is going to be at 50 and 30, and that this point right here is going to be at negative 50 and 30. So I've got 2 points on my parabola, and I have my vertex, right, and my vertex is going to be at 0, 0. So again, since I know the vertex, okay, I'm going to go ahead and just do the vertex form of the parabola. So y equals a times x minus h squared plus k. So in order to use this, right, I need to know a, h, and k. Well, I know what h and k are because they're right here at 0, 0. So I know that h is equal to 0, and I know that k is equal to 0. But I don't know what a equals, so that is what I'm going to have to find. So in order to figure out what a equals, if I know an x and a y, then I can plug numbers in for y, x, h, and k, and then as long as I have numbers for everything else, I can figure out a. So if I look on my parabola, I know 2 other points. I know this point at negative 50 and 30, and I know this point at 50 and 30. So I can pick either one. So I'm going to set x equal to 50 and y equal to 30. So I've got enough information now to figure out a. So let's go ahead and replace all of the letters with their appropriate numbers. So y is 30. I still don't know a. X is 50. H is 0. And k is 0. So if I go ahead and simplify this, I get 30 is equal to a. 50 minus 0 is 50. And if I add 0 on the end, I don't have to write it. So I have 30 is equal to a times 50 squared, right? So 50 squared, 2,500. So a times 2,500. And now I'm almost done. I've simplified as much as I can. Now I need to get a all by itself. Remember, when you're trying to get a by itself, we've got to get rid of this 2,500. We can't just remove it. We've got to do some math to remove it. So the easiest thing to do is to divide by 2,500, because 2,500 divided by 2,500 is 1. So what that means is that we'll have 1a, so a will be all by itself. But remember, what you do to one side, you have to do to the other. Okay? So now I know that 30 over 2,500 is equal to a. And just as a reminder, right, well, you want to simplify this. So we end up with 3 over 250 is equal to a. I just literally divided 30 by 10 and got 3, and 2,500 by 10 and got 250. So the equation for that part of the parabola is going to be y is equal to 3 over 250 times x. Well, we said it was x minus h squared, which is 0 plus 0. And we want to go ahead and write this a little bit nicer. So we have 3 over 250. X minus 0 is just x, so it's x squared. And then if we add a 0 on the end, it doesn't it doesn't do anything. So all that's happened here is there's like a stretch going on, okay? Or a compression, sorry. So the next one that we want to look at, let me grab a different color pen here, is, well, why don't we just do this parabola, okay? So I know that this point right here, okay, is going to be 50 meters, right? So if this is 50 and I add another 50 meters, this is going to be at 100. So if I look at this parabola right here, this purple one, I only have half of it, but that's all I really need, right? When I have the purple parabola, I have a vertex and I have a point, so I can go ahead and do the exact same work that I did here. Okay. Now, one thing that you might note is that since these cables are all the same, okay, they're gonna have the same shape, right? From here to here was 0 to 50, and from here to here is 50. So this shape and this shape will be the same. And if you notice that, then you can assume that your A value is the same. All right? So Y then is going to equal 3 over 250, okay? And then here my H value is 100, so it's going to be X minus 100, whoops, yep, 100 squared, and my K value is 0, so plus 0. And since it's plus 0, I'm not going to write it, okay? If you didn't see that, you'd have to go through this whole procedure all over again. And then the last one, okay, so that's this part right here, right? So to get from here to here, it's the same thing. So now I'm going to go another 50 meters, so I'm going to be over here. My vertex is going to be at negative 100. So again, right, it's just these cables, and again, if you realize that these cables are the same shape, you're just using part of it, then you can assume that your A value is going to be the same, which is 3. So I'm just going to do the black one down here. So this is 3 over 250, okay, and I'm going to do X, and then I've got my H value here, which is negative 100, and my K value, which is 0, so it's going to be X minus negative 100 squared plus 0, so I'm not going to write the 0, and then I want to simplify this a little bit, so I get Y equals 3 over 250 and X plus 100 squared. So this is the third one. Let's just put a little 3 here. The purple is the second one that we did, so let's just put a little 2 here. And then the red one is the first one that we did. So I'm just going to put a little 1 here so you can see what we did. And what we realized really early on is that we didn't have to calculate our A values again, because all of like the same parabola, right? It's going to be, the shapes are going to be the same because it's the same distance between the vertex. So we're making that assumption that our shapes are the same because they're at the same height where they get attached and they fall to the same point. So that way we know that our A value, which talks to us about the shape, isn't going to change. So the last part of the question says, for which X values is the equation valid, right? If we just left this equation, it's going to go on forever, and it's going to be also over here. So we're only looking at part of the parabola. We're looking at the part of the parabola that goes from negative 100 to negative 50. So that's what we're going to write. We're going to say that our X values are between negative 100 and negative 50. So these are the X values for which this parabola is valid, okay? Then we're going to look at this parabola, and we know that our X values go from negative, right? The parabola, again, can continue all the way up, but what we're noticing is that the parabola is only being drawn for the parts that are between the X values of negative 50 and 50. So over here, we're going to say where X is between negative 50 and 50. All right, so x is between these, and the way that we put that mathematically is we use the less than and equal than sign. It can also be at negative 50 and positive 50, so that's why the equal sign is there. So if we go ahead and think of the last one then, so this part of the parabola is only drawn between 50 and 100. So again, we're going to say where our x value is, so is between 50, right, and 100, and x is between them, and we're going to go ahead and use the less than or equal sign to say that, right, so x is always more than 50 but less than 100. All right, tens, I hope that helps.